Yeah.
So we disassembled a hair dryer. Example. So here's a bunch of pictures we took. So the first two are like the before, and then like it just goes down in the process of when we're taking it apart. And then here's more. So this is like we just take off the covers, and this is like the inside of it. And then once you open it up, that's the motor, the heater, and all that connected. And right there in the first one, you can see the motor is connected by a couple wires. So we had to snip those off, and you can see at the very last one, the first row, where we did that. So it disassembled, so these are two separate pieces. And this is like the heater with the coils and everything. And then the second picture on the last row right there is the motor and the fan all put together. And then more pieces, we just took it apart thanks to Jack. And then the motor at the end over there, yeah, we had to have Jack rip it apart. JBL. And then sketches right there, they have functions on them, like we have listed. You can kind of see it, but like the first two are basically the covers, it holds everything on the inside. And then the third piece right there is like the filter. It filters out the, so when it sucks in the air, it filters out the lint and stuff so it doesn't clog up your motors and stuff. And then fourth piece is that fan, or the turbine, I mean. It like spins, sucks in the air. And then fifth piece there, it like helps keep the heat path so it's directed onto your head and doesn't just like go everywhere. And then that sixth piece actually goes inside the very first one up there. It's kind of like the heat resistant. Make sure the heat doesn't melt the plastic away. Kind of keeps the product together. It's kind of like a cheap piece, but like really effective. And then sixth piece down there, that's just the motor. And eighth piece is what keeps the motor and the fan thing connected and helps keep the wind from coming in and like shooting out the heat. And that next piece really had no use. It was just a clip that you put over the motor and it just stated the model number and stuff. No real use. Oh, and by the way, the motor was magnetic. That really mattered. And testing for my component, I chose to make that fan right there. It did not produce any electricity. It was not magnetic, and I don't know if you can see it, but there's like, it can be scratched. It's like right here, I scratched it. You can kind of see some lines. I put that picture in there for. And so yeah, it can be scratched. And then the mass, we weighed it to be 12.26 grams with a volume of 22.8 milliliters. And got the volume by water displacement. Just like put it in a beaker, and whatever spilt out, pour that into a cylinder, and that's what I used. And that's what I got from my density when I did my math. I don't think it was accurate because I don't know if the volume was 100%, but because that's like 0.5377, and the one I got off Inventor, you kind of see it like right here. It's 1.06, so it's like a big difference.
What are the units for that one in Inventor?
Grams per centimeters cubed.
Same units? Okay. Well, that's a easy one. Just throw it in some water. Does it sink or not?
No, it actually floated.
It floated? Then yours is probably more right. So what happens is, an Inventor, you put in a certain type of substance.
Plastic, yeah.
Right. And so it probably wasn't that substance because it was, water, the density of water is 1. So if you put something in there and it's greater than 1, it's going to sink, and
yeah.
Yours floated, so yours is probably more accurate than what that one is.
Yeah, so I had to use a pencil, kind of push it down a little bit so
Right.
it's submerged.
Yeah.
So, yeah.
So the material Inventor must have been some other type of plastic than what you chose.
I predicted it to be ABS plastic.
Yeah.
So.
what you can do later is go in there and just keep on changing the plastics to different things until you get a density close to what you got. And then that's probably a good idea that might be the kind of plastic it was.
And so these little flaps right here, these can bend if you try to, but like the whole piece itself does not bend. It's just like little flaps. And then so like I tried screenshotting the whole thing, but like you couldn't see the dimensions, so I kind of zoomed in on each individual one, so it's kind of easier to see. These little circle ones here are kind of hard, but you can still barely make them out. And the way I made it on Inventor was, I did everything, but like for these flaps, I just made one and then rotated it around in Access. It came out kind of good. And it's really cheap. It's crafted from like a usable mold. They use hot plastic to kind of mold it out, and it just forms that way. And then it's created and shipped from China. Here's some pieces that are very similar. They all go for like $5, $6. And that's, so they're actually kind of making a profit because for each cubic centimeter, it's only like 4 cents of ABS. Well, it's because I predicted it to be ABS plastic, so that might not be pretty accurate, so. And that is it.
Whoa.
Yeah?
Isn't there supposed to be 2 parts?
Oh, yeah, let me go back. That's Lucio's part.
Where's Johnny's part?
I don't know. Public school system.
Any other questions about Lucio's part?
Oh, I can't ask anything else?
Yeah.
Because like I noticed like you did all the talking, right?
Oh.